Hey everybody. This video is really a remake of one that we put out a couple of years ago. We did a toolkit video for IQ, and some of you guys in VRC may not have watched it because you say, oh, it's an IQ video, it doesn't apply, it's not helpful. Well, I think it sort of probably does apply and probably is helpful. But we said, well, we'll redo this with VRC V5 and put the video back out here. It's concerning how to get your autonomous almost perfect on the very first try. And some of you are sitting there and you hear this and you think, okay, that's impossible. That's okay. And some of you think, okay, maybe it's not impossible, and I'd really like to know how to do that, because autonomous is a major pain in the butt. You know, it takes a long time to get it done correctly. And you know how autonomous usually goes. You put the bot out in starting position, you turn the motors on for some length of time, then you stop them, you do a turn, maybe you run your lift, maybe if you got a clamp, or you do whatever. And you keep guessing at these things, okay? Maybe you're one that does it by time. Okay, we're going to turn the wheels on for 1.2 seconds, move forward. Or we're going to turn the wheels on at 60% speed or 80% speed or whatever. But what if you could run the bot, you could drive the bot by hand and have the bot tell you exactly how far it had moved. If it moved forward 10 inches or 12 inches or 13.6 inches or however far it moved, forward, backwards. When it turned left, if it moved 10 degrees, 80 degrees, 77.2 degrees or whatever. And the same thing for the lifts and clamps and other mechanisms in your bot. Okay. Then you could write the code, put all those numbers in, and you're going to find that the code's going to be very, very close to working perfectly on the very first try. So that's what we've got here, okay? That's what we've got. Let me think. I'm trying to get this all on the first videotape. Let me think if there's anything else I need to say before we go look at the code. And I think that pretty much covers it. Okay, let's go look at the code over here. We've got our code gremlin.
We named our code the toolbox or toolkit because that essentially is what it is. And it runs by having, whenever you hold down a button, the robot moves a certain amount and it displays it to the brain, as you can see here. Instead of using we use buttons instead of joysticks, as you cannot accurately move both joysticks the same amount, but you can essentially with buttons. So
all right, I'll keep. Yeah, sorry, I interrupted. Sorry about that.
So we have button R1 makes our intakes move a certain amount, and instead of doing 3 if blocks, we use 1, and you can go in here and put down different commands. If whatever is here is true, then run this. If whatever here is true, then run this. And if neither are true, then run this. And we have that for essentially everything: moving the wheels, intakes and lift, turning left and right. And then
let's go back up, scroll back up a little bit so they can see, so they got time to see all of this. So you've got what's in the first group of blocks here?
If button R1 is pressed, then intake left and right, then forward at 100% velocity. And if button R2 is pressed, intake left and right, then reverse at 100%. And if neither of these have been pressed or are being pressed, then they break.
Okay. The next section.
For L1, it's lift front and lift back, or if L1 is pressed, then lift front and lift back, bend forward at 100. And if button L2 is pressed, lift front and back, move reverse at 100. And if neither are being pressed or held, then brake. And
let's skip that section. Come back to that section.
Whenever button up is pressed, then the 4 wheel motors will spin forward at 40%. The reason why we chose 40% instead of like 100 or something is the robot is stationary, or usually is, until you press this, and if it is stationary and you press it all of a sudden, it'll jump basically, and it won't be very accurate and it'll be inconsistent. Button down is pressed, then all the wheel motors move backwards or reverse at 40. And if button left is pressed, then you do a left turn at 10% speed. If button right is pressed, then you do a right turn at 10%. And then if none of these have been pressed, then it brakes. And
let's go back to the display.
Whenever you, or let's say you do a left turn, it'll display how many degrees the 4 wheel motors have moved, and you can write that down on a notepad or something. And whenever you press button X for us, you have it reset these commands so that you don't have to subtract how much you did from the previous move to see how long you went in the new move you do. So if you turn and then go forward, you reset it so that you don't have to subtract the turn to see how much you went forward. And I'd say that just about covers everything in the code.
I mean, the code's not particularly complicated, and it's like he said. You start out, say you do a forward move, you hit the button, the robot moves forward as far as you need it to, and then you let off the button, the robot stops, then you look at the brain and write down the settings, or record what it's telling you, how many revolutions it turned, how many degrees it turned. You hit the button X, and where'd the code? There it is. Then it resets all those things, so they're all set back to 0. Then you're ready to do the next phase of the moves. If you want to do a turn, if you want to back up, if you want to turn your intakes on, or clamps, or flippers, or whatever it is. But the teams have been using this code for about 3 years now, and it'll get your autonomous. If you do an autonomous run this way, write it all down, and then program it in, then it'll get you really, really close on the first try. And then after that, you got to fine tune it. I mean, it's not perfect, but it'll get you really, really close on first run. So, anything else you want to say?
No.
So, okay. Well, hope everyone enjoys this and gets some use out of it. And we'll see you guys at Worlds.